Well, hey, internet students, Dr. Z here. Hope everybody's doing well. I just made myself a second cup of coffee from this morning's cup of coffee, so I'm feeling very vibrant right now and going to get 2 videos done today. Well, welcome to All Things Water, H2O. And for you chemical engineers, you know that's 2 hydrogen atoms connected to 1 oxygen atom. So for the tools and supplies for this, it would be a hammer, cordless screw gun, high impact drill, tool belt with ample supplies, level, drill bits, screwdriver drill set, backhoe, PVC cement and primer. Of course, we're going to do PVC once again, just like in the electrical video. We've got different types of PVC for water though, but it's still PVC pipe. Liquid foam to seal off the incoming pipe, origination pipe coming into the house. Copper pipe to pipe into your jet pump. Flux, blowtorch, brackets, jet pump. Spec'd out water cistern, which I'll explain in this video in detail. Jet pump, electrical hookup, supplies and pressure gauge. You're also going to need a pressure tank and water filter to the size and likings of your family. I used 80 gallons because that was the biggest that they had, and I wanted to make room for a family coming in here. So, also my little comment about H2O, I have organic chemistry and also chemistry done through electrical engineering, and I also did pre-med classes as well. So I thought that would get some of you, maybe microbiologists or medical students out there. You'll see in my propane chapter, I actually draw out the 3 carbons for propane and actually have the hydrogens connected properly. So you might like that video too, if you're into molecular structures. All right, the student should understand by the end of this lesson how to meet with a vendor and spec out your water cistern. Select the proper jet pump and with the horsepower and voltage that you would need to sustain your family and any additional family members that may come aboard later in life. Dig a hole to the proper dimensions for the water cistern, insert water cistern into the hole, level it, and correctly pipe the water cistern into the home full of water. And then hook up the jet pump inside the home with the proper electricity. In my case, it's 110 volts, not 220. And then water filters and valves. The student will create a document depicting their future water plans of their off-grid retreat and do-it-yourself project plan. Okay, so remember your project plan. This is going to be the milestone for all things water. Okay, students. Now, full disclaimer here, I did not dig a well as of yet. I used a water cistern. They've had some issues with wells up where I'm at. It's kind of spotty. We've had some folks up here dig and find a nice aquifer, and they're getting, 3 gallons per minute out, and they're watering their crops and their farms and everything. However, many more people have dug wells and have not hit a aquifer as of yet. So it's a kind of a crapshoot that I don't want to kind of spend at the moment. I want to kind of spend that money on something else. And depending on how deep you go, I mean, like a 250-foot well could cost you upwards of $17,000 to $20,000. And if you don't hit water, you've just lost $20,000. So just full disclaimer there. And as of yet, I still do not have in my water filter. I know that I still need to get a move on with that, but that's coming next. And we'll cover that in this video. All right, step 1, planning the milestone. The first step is to consult your certified architecture plans. As your students are well aware, you should have had an architect draw up your homestead. It's much easier to build from because you're not actually a builder like I'm not. So architects already know loads and beams and everything, and they actually label everything. I think my plans came out on full sheets. They're like 4 feet long by 3 feet or whatever the architect sheets are. I had 7 or 8 pages, and the architect did everything from footers, details, placing anchor bolts in walls, number of floor joists, all the way up, stacking logs. There was a schematic on logs, and all the logs were labeled. All I had to do was pick them from a stack and put them in. Ceiling trusses, everything will be depicted in your certified architect plans. And that's why I say if you're going to be a DIY person, do it yourself person, students, you're going to have leverage from somebody else's experience. And architects are excellent because when they design blueprints, you know that they've already got load bearing walls figured out. They've already got the ceiling trusses already mapped in. They've even got the screws and the bolts and the kind of nails that you're going to be using. And it was easy. It was kind of like building a Lincoln log set as a child. But so that's just a little tidbit for you. I recommend having an architect write up your plans because it's going to be a lot easier for a DIY person like yourself. All right. So as far as a milestone is concerned, once you check this off, it's now a good time to have a phone call with your local water cistern vendor. Where I live, I just drove up there and told him what I wanted, and he said, "Yeah, we make this. The 2,500 gallon one is the biggest we make." And I said, "Well, can I order two and concatenate them?" And he says, "Nobody's ever done that." So he's like, 2,500 is just good for you. So I went with that, anyways. It takes about a week and a half for them to put it on the schedule and actually make it with concrete. I recommend using a concrete water cistern. I know it comes in two parts and you have to seal it in the center. However, the water cisterns that they sell that are even bigger than 2,500 gallons, like 5,000 or 10,000, which are plastic, do not last in the ground up here. And that's something I want to relay to the students is beware, you might invest all that money, but then you may have to dig it up at a later time and replace it with a concrete one. All right, step 2, excavating for your water cistern. At this point, your backhoe should be arriving on the property from the rental company. Go ahead and begin excavating from your spray painted lines, which you've already put in the ground. You're probably a professional at doing this. Remember, anytime you dig a hole, leave 2 feet extra all the way around it because you need space to walk around, what you're inserting in the ground. Whether it's a propane tank or water cistern or a septic tank, you're going to need room to walk around it. Remember to use a 2x4 with a level on top to level the bottom of the hole. In other words, if you get a 2x4 the length of the hole, I'll put a level on it and then just slide it across the bottom, and you will see that there's some divots or maybe some high spots you can kind of take out with a rake or shovel. But when you're done, you should be perfectly level. Again, make sure everything is level no matter what you're installing in the hole. At this point, you should have also dug a trench from your house wall. This trench must be 1 foot below frost line for your region, so make sure you understand and do your calculations, students, on that. For me, my frost line was 6 feet below the surface, so I went down 7 feet. And of course, in your region, it may be different, so make sure you are below the frost line when you insert that water line into your house. Otherwise, it's going to freeze up in the wintertime, and it's going to be pretty nasty taking a shower and having your shower turn off automatically because your line is frozen outside. So remember, you're going to have to drill through 8 inches of concrete because that was the width of the wall. And I used a 1-inch PVC water pipe insert from the water cistern into the home. So I needed an impact drill that would make a 1.5-inch diameter hole through 8 inches of concrete. And what I did, students, was I laid on my belly in the hole, and it took a good 10-15 minutes to get through that wall. I would just light up that impact drill and then just push as hard as I can with upper body strength, and then rest and push some more pull it out, push some more, pull it out, push some more, pull it out. As you're pushing in, you're actually routing the hole. And as you pull it out, the drill is still spinning and it shoots the concrete bits out. And so it kind of cleans the hole, and then you can drill into it even further. And so that's what I did. It was a continuous process for about 15-20 minutes, but finally I broke through, and that was it. And I was inside the house. So step 3, pressure tank. Again, I talked about an 80-gallon pressure tank. You can use 40-gallon, 20-gallon, whatever you think you need. I know RVs have pressure tanks, and they're usually smaller than that. Since your water cistern will not likely be completed for another few days, and your hole is dug, and your hole is drilled, install the pressure tank inside your basement and level it properly on the floor or on blocks. Don't forget to install the straps. These are earthquake straps to hold it in place. Plumb it to your PEX feed, which is plumbing, from our plumbing lesson previously, and ensure that there's a one-way union, in other words, one-way direction that the water can flow, so it can't flow backwards into the pump. And then plumb that correctly to your water tank and get it ready to plumb your jet pump. The output of the pressure tank will be just cold water line feeding the rest of your system. Remember that you have to feed your hot water tank cold water, because then the hot water feeds the rest of your household appliances. So you're not going to have any hot water at your pressure tank coming in from your water cistern outside. And I'll draw up a diagram for you guys so you can see it. Step 4, jet pump. Now go ahead and wire up the jet pump inside your basement. You need to install rubber grommets underneath the base of the pump, so when it jiggles, due to it being activated, it doesn't vibrate the bolts and pull them through the concrete floor. Ensure your jet pump is wired correctly to either 110 volts or 220 volts, depending on the pump that you have purchased. And remember that the jet pump actually is used inside the house. However, they do sell jet pumps which are used inside of a well, which can be submerged in water, and they can go down, 250 feet even. So, make sure you understand the one that you're getting is going to be to fill up a pressure tank from a water cistern, and you're not pumping water out of a well into your home. Those are 2 separate jet pumps. So a special tip there for your students. It's also a good idea to go ahead and plumb your jet pump to your pressure tank. And what I mean by that is my pressure tank is on blocks and it's leveled perfectly. Then I used earthquake straps to strap it to the wall. Not I'm afraid of earthquakes. I don't want that thing ever tipping over. And then the jet pump is bolted to a pressure-treated piece of plywood, which then is strapped to rubber grommets, which then rests on the floor. And then I bolted the entire pressure-treated plywood into the concrete floor through the rubber grommets. And then that gives it enough play when it vibrates that it's not going to pull those bolts loose. So that's another tip for you. And then the output from the jet pump, remember to use copper because it's more durable and stronger and is able to secure to the wall and floor properly than using PVC. Because of the vibrations of the pump, I don't recommend PVC except the connection coming through the wall. And then that would be it. And then there's actually a special PVC filter that they sell, which I used. And then from that filter is when I went ahead and translated from PVC into copper, and they have a fitting just for that. And then all of that was used. And then a special warning to you folks is please understand that there's copper, there's galvanized, there's steel, and there may be even titanium or stainless steel or something to that effect. You must not use different types of metal because that will corrode much quicker and also be more costly later on in your project life cycle. If you're going to use copper, stick with copper metal the entire way. Always use the same kind of metal. So, and that is, you can't mix metals because it actually corrodes faster. If you put a steel L-shaped spigot from your water pressure tank and you use galvanized plugs to plug up the holes, the ones that you're not using, usually they're used for pressure gauges and stuff, you will actually have more corrosion at that point because of two metals, different metals going against each other than it would be if you just use the same metal throughout the entire system. So that's a tip. Step 5, water filter. Again, I recommend putting in a water filter. The reason why I didn't put mine in is because none of the home and garden stores sold what I wanted. I not only wanted the water filter that filters out chlorine, filters out iron, oxidous materials and things like that. I also wanted it to filter out microbes, which includes cysts, bacteria, and also viruses, and they do sell those. So I got one on order, by the way. So students, it's going to be installed, but that would go between. It depends. If you want clean water to go through the entire system, which would be the jet pump and everything, I would recommend installing it as early as you can in the system. For instance, mine's going to be installed right at that feed coming through the wall, and then the entire system will have clean water going through it, including going through the jet pump, going through the big filter, particle filter that I have, going through the union, going through the pressure tank, and then going through the PEX, and then going into the hot water tank, and then feeding the rest of the house. Everything will be pure water at that point. Well, as pure as you can get it, 99.99% pure. But that's coming up next, so that will not be in these pictures, but it will be in the diagram that I show you. Step 6, installing water cistern. At this point, your water cistern should have arrived on your job site. Motion the crane operator over and get him lined up to the hole. Work out hand signals with him and let the process begin in hoisting the 2-part water cistern into your hole. The bottom part comes off the truck first, and you'll be standing in the hole. You're going to have to help the crane operator on this one. He doesn't come out with 2 guys. You will twist the water cistern with your biceps, use some muscle, around until it's lined up to your desired needs. Then he'll lower the lower half of the water cistern into the hole, and then you will take your level and level all 4 sides. Be sure to kick some sand under the sides to make sure it's totally leveled. Remove the straps off the lower portion of the water cistern and allow the crane operator to hoist up the top portion. He will toss you a roll of sealing tape. Essentially, this is like Play-Doh, okay? As a kid, you probably played with Play-Doh. You're going to unroll the tape and seal it all the way around this big, huge rectangle that has a groove in it. And then you're going to use hand signals again to hoist up the upper half of the water cistern. And then this will stabilize it, by using your biceps, and then twist it until it's totally 100% lined up on the bottom half, which is already resting below your feet. Okay, so now you have to marry the 2 pieces. This is be some fancy footwork by the crane operator, who'll probably just tap the button once or twice, and then it'll come down very slowly for you. But you just make sure that you marry them very snugly and securely. And that Play-Doh that you put on, that tape, will be your seal once this thing gets totally dropped into place. Now you should see a 3D rectangle with a hole on top. This, you'll also have sealer around that. That's actually the hole, a manhole, in case you have to get into it and do maintenance someday. You can climb down through that hole. You can see from my picture. You also have to place the concrete cylinder on top of that, and then there's a heavy lid on top of that. And then inside the lid is a plastic opening, and that's where you would fill it in future instances of filling up the water tank. Now wave goodbye to the crane operator and line up the truck for potable water. Typically these trucks carry 3,500 gallons of water. After I had the first potable water truck come on, remember about OPSEC? I keep saying that. I don't like people coming onto the property, and neither will you eventually. You just want to be totally left alone and off grid. So once I finished filling this up all the way in one truckload of potable water, I have a 210 gallon water tank that fits on the back of my pickup. And anytime I go into town for anything, supplies or grocery shopping or church, I just fill that up and bring it back. And I've never had to call that truck back again to fill up the water cistern. So just a little tip for you if you want to keep clandestine where you live. Step 7, turning on H2O. Okay, for your chemical engineers, that's water. The last final workmanship step, you're going to put the PVC connection, a 1-inch pipe extending from the basement wall from your water cistern. Then be sure to connect to the 3/4-inch PEX to the cold water manifold line. And you also have to ensure that your water tank is hooked up to your manifold. If you see from the picture, I've got the cold water PEX lines, which are blue. Then I've got the hot water lines, which are red. You've also got to hook up from that manifold a 3/4-inch PEX line all the way to the hot water tank. Remember that cold is input, blue, and then red is output, which is hot. So this is very imperative. You got to make sure that this is a foolproof system. It's totally sealed off before you turn water on. Tip, they sell water valves that go down past the frost line outside. So when you bury your PVC outside, you could actually put a water valve there that would go up 6 feet outside, so you could turn it off in the wintertime in case you're not there year round. I would recommend that. And then you could turn it back on in the springtime when you come out, and that way you would have no water inside the house, and you could actually clean out your water system every year by draining it, and then you could come back and forth when you wanted to. So all right, so once everything is plumbed properly, it's totally sealed off. You can even pressurize the system to see if there's any leaks, but I didn't have to do that. I went ahead and turned on the water, and the water came through the input from the outside water cistern. It filled up the big particle. I had it filter out the big particle filter first, drain some out through there. Then it had gone into the jet pump. And special warning here, before you turn on your jet pump, you have to prime it with water first, which I did. And then as the water feed comes in from outside, the two waters will connect. And when that happens, then your jet pump is ready to turn on. So make sure it's in the off switch until you get the water system primed up to the jet pump. Once that's done, jet pump turned on and pushed water through to the 80-gallon pressure tank. And of course there's valves and also emergency release valve. Make sure that's closed. And it also has a pressure gauge. And it's going to go, I think it's 18 PSI. It's pretty much where it's at now. But that filled up, and then jet pump didn't shut off yet. It's still pushing water through that cold PEX line, the manifold that you see there, then over on to the hot water tank. Now again, make sure your hot water tank, this is a big warning, is not on until it's filled up. So once the hot water tank fills up, I have a 40-gallon tank, then I was able to shut off the hot water valve coming out of the tank. And then I knew the whole system was pressurized at that point. And there was no leaks at that point, so I had cold water throughout the house. Then I went ahead and fired up the hot water tank. It's a propane tank, and let that heat up for, I think it was about 40 minutes or so, maybe 20 minutes. And then I opened the valve for the hot water line, and then I filled up the PEX manifold, as you see, the red one with the red lines, and then that filled up the entire house with hot water. At that point, I had water, and it was good to go. And so again, you want to test all your plumbing fixtures at the end. When you're satisfied, go outside. You need to backfill your water cistern hole in. Be sure you have the proper sloping in order to have correct water runoff. You don't want water sloping back in towards the house, which is towards the basement foundation. See the footer pour lesson earlier in the series if you have questions. And then, of course, in closing, you know what to do. Please like the video with that thumbs up button that you're looking at right now. Please subscribe to the channel because that gives us more views and also allows us to make money in the future. I think we can make $2 or $3 per every 100,000 viewers, which is not much, but every $5 helps. And then if you could donate $5, that would be great on our university website, University1310.org, where everything currently is free resources. I hope that you find these videos helpful. I also hope that you find our resources. Please drop us an email and give us some advice and some feedback on what we can do different and what you think would work better for our organization as you become more familiar with it. We love our students and we love your feedback, and we wish you Godspeed and God bless, and may you have a happy and safe DIY project. And drop us a line on what you're doing in your DIY project. We want to hear what your takes are and how you're doing and how you're progressing. And I hope that you're writing these paper and getting things out of it. God bless.